Hi grade 12s. Today we are going to be going through our last video. Look at that. Congratulations, everyone. So this is 5.10. We're going to be talking about salts as well as titration curves. So we'll add in a little thing at the end here too. Okay, so lesson 5.10. Okay. Oh, there we go. Sorry. Okay, so salts. Now you have the handout for this already. Salts consist of a metal ion and a non-metallic ion, or a metallic ion and a non-metallic polyatomic ion. So examples of these are things like sodium chloride, sodium sulfate, etc., right? Salts can be formed in different ways, but the ones we are going to talk about are the ones that are formed through acid-base neutralization. So again, we've got, your acid plus your base is going to go to salt plus water. So we are concerned with these salts here, okay? Now we have something called hydrolysis. So the process of hydrolysis. So some salts are going to dissolve in water. So when something hydrolyzes, it's going to react with water, okay? So some salts dissolve in water and produce a solution that is not at pH 7. And we wouldn't think that, right? So when we've got a straight acid plus base, again, goes to salt plus water. This is a neutralization, and neutralization we define, as the pH equals 7. That's your neutral pH. But we know that sometimes we have neutralization equations that, or reactions that result in a pH that is not 7. So it'll be either a little bit above 7 or a little bit below 7. Now, when that happens, we know that the salt has acted as an acid or a base. And so that's what we're going to look at today here. So first of all, we've got a reaction here between sodium hydroxide and hydrochloric acid. So these are both strong, right? So we've got a strong base and a strong acid. So when we have a strong acid and a strong base, we end up with a neutral solution, and that's because the salt does not hydrolyze here. So the NaCl is not going to react with the water. So when we have a neutral salt solution, it is produced by a strong acid and a strong base. Now, if the salt was produced by a strong acid with a weak base, for example, the resulting solution is not going to be pH equals 7. It's going to be slightly acidic. And we're just going to take you through an example here showing this. So for example, we have HCl plus NH3. So HCl is our strong acid. NH3 is our weak base, right? And they are going to produce this salt, so NH4Cl, so the ammonium chloride plus water here. Now, what we need to remember is, let's take a look at this weak base here. We've got a weak base. When a weak base reacts, you're going to end up with NH4 plus, and that's going to end up being your strong acid, right? Because the conjugate acid is going to be strong. Remember that? So if we have a weak base, the conjugate acid of that will be a strong acid, right? So what that tells us is that this NH4 here, NH4 plus, sorry, I should say, because it came from a weak base, the NH4 plus is actually acting as a strong acid here. And because it's a strong acid, it's going to hydrolyze with the water. So it's going to react with the water, and it's acting as an acid, so it's going to donate a proton to the water, leaving us with some H3O plus. So this is why we get an acidic pH. Because that NH4 plus that's in the ammonium chloride salt is reacting with water or hydrolyzing to create the hydronium ion, to make the hydronium ion. So that's going to leave us with an acidic pH. So this is called hydrolysis when this happens. So in other words, an H plus ion is either split off or added to the water. Now, if the salt is the product of a weak acid and a strong base, then the salt solution is going to be slightly basic. So hydrolysis occurs when the conjugate base of the weak acid reacts with the H3O plus ions, causing an excess of OH minus in the solution. So let's take a look at this here. So we've got a strong base and we've got a weak acid here. So we've got sodium hydroxide, our strong base, but now we've got a weak acid, which is our acetic acid here, and it's forming the salt, the sodium acetate here. So if we look at sodium acetate, this will dissociate right into Na plus and CH3COO minus. So we know that we've got CH3COO minus in that solution. Now, acetic acid, this one here, is a weak acid, which means the acetate ion is going to act as a strong base. And strong bases are going to steal a proton. They're going to accept a proton from the water, or accept a hydrogen ion from the water, leaving the OH minus here. So because we end up having OH minus in the solution, we get a pH that is slightly basic here. So that salt is going to hydrolyze. Okay. So summary. So a strong acid plus a strong base, neutral solution. A strong acid and a weak base is going to end up with an acidic solution. The salt will hydrolyze, leaving an acidic pH. And if we have a weak acid and a strong base, we end up with a basic solution, because the salt will end up hydrolyzing, leaving us with a basic solution. Okay, so we're going to go through some examples. This will make more sense as we go through this. So determine the solution type produced by the salt KCl. Now in your notes it has KCl and the ammonium nitrate, so we're just going to, it's not together, we're just going to do one at a time here. So KCl first of all. So KCl is our potassium chloride is a salt, so it's going to dissociate into K plus and Cl minus. So looking at this, you have to sort of imagine where they came from, right? So the K plus came from the base, and so it probably came from KOH. Cl minus came from the acid, which would have been HCl. So I know this because this is from group 1 on the periodic table. So I know that group 1, when they're bonded to OH minus, form strong bases. So I've got a strong, this salt, the cation here, the K plus came from a strong base. The Cl minus came from is the conjugate base of HCl, which is a strong acid, which means it is going to be weak. So that came from a strong acid. So for this particular example, I had a strong acid plus a strong base. So I'm going to have a neutral pH here. So that's going to be a neutral solution because the conjugate acid of a strong base and the conjugate base of a strong acid are weak. So they are not going to be able to hydrolyze. They will not react with the water. Now, this one, we've got NH4, so ammonium nitrate. So if I look here, ammonium nitrate, this is my salt. So I have to think of ammonium nitrate dissociating. So it's going to end up with 2 ions, so the cation being NH4 plus and the anion being NO3 minus. Now I have to think about where these things came from. Now NH4 plus, this would be from the base, so it came from NH3, which is a weak base. Now the nitrate ion is NO3 minus, so this came from HNO3, which is a strong acid. Now the strong acid, a strong acid will have a weak conjugate base. So that means I don't need to worry about the NO3 minus. It is not going to hydrolyze because it's weak. But I do need to worry about this NH4 plus. NH4 plus came from a weak base, which means it is a strong conjugate acid. So that said, the NH4 plus will hydrolyze, so it will react with water, and you should write your equation down, and that's going to become NH3 plus H3O plus. So that NH4 is going to act as the acid, so it's going to donate a proton, give a proton to the water. And because of this, the presence then of H3O plus, we know that the pH will be acidic. Okay, so that is how you do these. Now, I provided you guys a flow chart here. some people like this. It's just a way to kind of keep it separated and keep it all sort of clear in your mind, right? Now, knowing this then, so the question here is analyze sodium carbonate using the flow chart here. So your first step, you're going to write the dissociation. So 2Na plus CO3 2 minus. So let's go through the flow chart here. So looking at the positive ion, so I'm right here. Looking at the positive ion, is it from group 1 or group 2A, the periodic table? It's sodium here. Yes, it is. So does not hydrolyze. Okay, let's look at carbonate here. CO3 2 minus. Now that came from carbonic acid here, right? You know what, I just need my, sorry guys, just give me a second. Yeah, okay, sorry. So CO3 here came from carbonic acid. So did it come from a strong acid? No, it did not. So you can use your Ka table for that, and the first 6 are the strong ones there, and everything else is weak. So no, it did not. So that tells you that this pH is going to be basic. And I'd like you to write the hydrolysis equation. So the hydrolysis equation here, you are going to take CO3 2 minus plus water, because the CO3 2 minus came from a weak acid, which means it is a strong conjugate base. So it is going to take one of those hydrogens to make HCO3 minus, so just one, it's not going to take 2, it's always 1 proton at a time, leaving OH minus left over. And this is why we end up with a basic solution here. Okay, so again, the carbonic, the CO3 2 minus came from carbonic acid, H2CO3, which is a weak acid. So the weak acid will have a strong conjugate base, so the CO3 2 minus is going to act as a base when it hydrolyzes. So it's going to react with water, it's going to steal one of the protons, leaving HCO3 minus plus OH minus. And that is why we end up with a basic solution here. Now, question, what if they both hydrolyze? So this can happen. So this is when we have a weak acid and a weak base. So in this case, both the conjugate acid and the conjugate base are going to be strong. So you need to figure out what is going to happen. Now, basically, you have to figure out which one is going to win, right? So which one is going to get to hydrolyze with water. And we have a way to figure that out. Maybe some of you have figured this out. We are going to look at the Ka and Kb values and see which one is stronger here. So we're going to look through this example here. So we've got, again, a weak base plus a weak acid. So that tells us both of these are going to hydrolyze here. So I'm just going to write the equations out, the hydrolysis equations, so we can really see them. So the NH4 plus, this is going to be our NH3 plus H3O plus. Now, and then I'm going to do the other one too. So if I have CH3COO minus plus water, this one's going to take one of the hydrogens from water. So now I'm going to have CH3COOH plus, and now it's going to be OH minus. So I've got these two possibilities here. So I need to figure out which one is actually going to happen. So I look to my Ka table for that. So I can find the acetate. Now where is it? So if I look here, sorry, the ammonia, oh man. The ammonia, let's look for the NH4 plus one first. It's the ammonium ion. You can find it there, and it's got a Ka associated with it. So I've got NH4 plus H2O going to H3O plus NH3, and I end up with 5.7 times 10 to the negative 10. So Ka is 5.7 times 10 to the negative 10. Now I need to find the Kb for the acetate ion. So I find acetic acid in your Ka table, and it's got a Ka of 1.8 times 10 to the negative 5, but I need to find the Kb. So remember, we've got the formula Kw equals Ka times Kb. So I can take Kw divided by the Ka, which is 1.8 times 10 to the negative 5, is equal to the Kb. So I can punch that in. Kw, remember, is 1 times 10 to the negative 14 divided by 1.8 exponent negative 5, and I end up with a Kb of 5.56 times 10 to the negative 10. Oh man, they're like pretty close here, aren't they? I hope I calculated that right. Let me just double check that. Whoops. Divided by, right, so 5.56, basically 5.6 to 5.7. So which one is bigger? Which one's the bigger number? So in this particular case, oh shoot, oh look, I gave myself all this room and I totally didn't use it. Okay, anyways, so let's look here. So Ka and Kb are here. So which one's bigger? It's going to be Ka, just barely. So the Ka is going to be the larger one. So that's the reaction that's going to happen. So therefore, I'm just going to recopy that Ka equation here. So NH4 plus water. This is our NH3 plus H3O plus, and I will say pH will be acidic. So that would be how I would answer that question here. So you're always comparing your Ka to your Kb when you've got weak acids and weak bases. All right. Okay, we're going to talk about titration curves. This is a fairly simple concept here. So you will have done your titration in the lab. So this is just a neutralization equation. Now, if you were to graph out your titration curve or graph out your data as you're adding base. So remember, we've got the burette, right? And we've got the flask. So this is your titrant in here, right? Known concentration, and you are dropping it into here. If we had a pH meter, let's stick a little pH meter in here. We could graph the pH based on the volume of titrant added, okay? So these curves, so you'll have pH here, and this would be volume of titrant. And we can graph the pH curves. Now, depending on if you're starting with an acid or a base, so you could get, they'll tend to look like this. So they start out just rising slowly, and then they have a big lift in the mid-range, and then they flatten off. So this would be when we would start with an acid. This would be, an acid in the flask here. We could also have the opposite happen if we had a base in here and an acid as the titrant. We would end up just having the opposite curve here. So just be aware of that. Now, the midpoint or the equivalence point is always right in the middle of that rise, okay? So the equivalence point, you can graphically determine it actually from plotting this. So you just would like literally measure from top to the bottom here of that rise here, and then the midpoint is where your equivalence point is, or your end point, okay? Now we've got 4 possible curves then to look at. So strong acid, strong base, weak acid plus strong base, strong acid plus weak base, and then we've got the 2 weak acids and bases here. Okay, so we're gonna go through each point here, or each kind. So type number 1, strong acid plus a strong base. Now we've already said that the equivalence point is going to be 7 at this point. So when you are neutral, the salt is the only thing there that's going to be contributing to the pH. So the pH would be 7 there. And you would just read that right off. So when you've got a strong acid and a strong base, pH is 7, and we know that by looking at the salt, because the salt will not hydrolyze, okay? So the equivalence point, pH 7. Now, weak acid plus strong base, For this one, remember the weak acid has a strong conjugate base. So that strong conjugate base is going to hydrolyze. So what? Whoops, I totally skipped. Hey, yeah, where am I? There we go. So this one, the weak acid has a strong conjugate base, which will hydrolyze. So the salt will hydrolyze for this particular titration. So this means that the equivalence point, the end point, is going to be above 7. So if you look here, it's 8 point something, right? It says right there, 8.72. And this is because the anion of the weak acid is going to hydrolyze. So it will react with the water to form some OH minus, and that will push the pH up towards the alkaline region. Okay, next we've got a strong acid and a weak base. So this one, the conjugate acid of the weak base is going to hydrolyze, so the salt will hydrolyze and will react with water, leaving the pH to be slightly acidic. So here it's just a little bit under 7 here. Next, okay, now for weak acid and weak base, again, we have to compare the Ka and Kb. So this is an example here. So if we look at the salt ammonium cyanide here, we've got NH4 plus H2O, and that's going to hydrolyze. So I've got my Ka value of 5.7 times 10 to the negative 10. But then if I look up my Cn minus on my Ka table and then calculate Kb, I get 1.6 times 10 to the negative 5. Now, Kb is the bigger value here. So that tells me then, since Ka is bigger than Ka, more OH minus is produced. So that means this reaction is going to win, essentially, right? And so the solution will be basic, and the end point then is going to be above pH 7. So you need to look at your Ka and Kb values then to solve those. Okay, that's it for this lesson. You can now do assignments 40. This is on salts. 41 is on titration curves, and then 43 is actually a review for the unit. As always, I do not expect you to do all the questions. Try some of them, read them over, make sure you sort of like plan your strategy, make sure you know how to approach them. Like I say, 43 is the review, so give that a try when you get a chance. And the answer keys are posted to this, so take a look there. Okay, thanks everyone.